talk about SatLeash. SatLeash is a project started here at Politecnico di Milano by some PhD students and some master thesis students that developed some models to catch space debris and to perform the deorbit of space debris. So the space debris was catched like with a tether, so with a cable. Like if you are in the West and you want to catch a horse, you jump with your lasso and you catch the horse. You can do the same plus minus in space, but the things are more complicated, because what happens if the cable, so the tether entangle, or what happens if there are some pushbacks, or if there are problems. These problems need to be solved, and so a appropriate control law was developed by these students. What I have done with them is only a little part of the project. I almost haven't done nothing, but I only developed a finite state machine in order to automate the experiment, because this kind of experiment, you know, space debris are in space, and you have to test the chaser and all the system in a microgravity environment. So, ci siamo. Ok. Ce l'abbiamo fatta. So now we have the presentation. I hope. Oh, good. Okay. Okay, and where is the presentation? Okay, okay. So I was talking. Okay, thank you. I was talking about those students. So this is the Polytether team responsible for the SatLeash experiment, and is mainly formed by these guys that are PhD students and master students here at Politecnico di Milano, and the project actually was endorsed by Professor Michel Lavagna, and here you can have a graphical view of what I was trying to speak about. So we have a chaser with a cable that want to catch a generic space debris that is indicated as target in the presentation. There is a lot of problem in doing this, because the tether is flexible, so you have to modelize with mathematical law how the tether can deform, how the tether can entangle, and then you have to validate this model by doing experimental test. The team SatLeash was selected by ESA, Fly Your Thesis program, to have a campaign of experiment in a microgravity environment that is recreated by doing a parabolic flight. in order to, as you can see, investigate how the things works in an ambient that is almost identical to the space one. You can see here at right how is the experiment organized. There are two guys. One of those guys have to control a computer. Another guys have to watch and move some interruptor on the rack that is the gray one. Here you can see that what are the components of the system. We have a main rack, that is the rack which have the control system, and a cube that in the inside have some sensors in order to reconstruct what is the dynamic of the system. And plus, in order to correctly reconstruct all the experiment, two cameras have been placed in the two sides of the room. So here you can see the complete mounting. Upper on the left there is the actual rack with the system that pulls away the small CubeSat that is docked by a magnetic sensor to a docking station. The CubeSat is the one on the right, and inside have a Raspberry Pi that is connected to an IMU in order to reconstruct what is the dynamic of the experiment. And I have speeched about camera and IMU, and the load cell was needed in order to log what was the tension on the tether. This was the main objective of the entire experiment, and in order to pull up this this debris, we have to, how I can say, to control the tension that is acting on the tether. So we have to control the thrust that is applied to the chaser. In order to realize this kind of control law, a wave-based control was chosen because that is based on the measuring of the absorbing mechanical waves at the interface, because it's simple and is enough robust for the purpose. And this is a view of the actual slider. On the right you have the hypothetical chaser, and on the left you have the CubeSat that is pulled away. And these are the result of the, actually this was a video, of the numerical simulation. This is with the controller off, and this is with the controller on. Okay, we've talked about this, and we have talked about the flight, and this was actually the rack mounted inside the airplane and the two CubeSat. And this is the video of the experiment, of the ongoing experiment. Perché non va? Windows. Oh, ce l'abbiamo fatto. So as you can see now there is the 0G part of the flight, and this is the experiment is done. Okay, so this was another video from the two cameras on the upper corner of the experiment. And as you can see, the control works because the cable does not entangle, and this is the reference if you want to, if you have questions. You can ask me some questions, but I can give appropriate answer because I'm not the person who developed all this experiment. I am only the person who performed the automation of the experiment, because you know when you are on the parabolic flight you cannot interact with the experiment, so the things has to be automated. So I have developed for these guys a bunch of Python scripts that automates all the experiment, and the only thing that the guys have done during the flight was switching some switches, and poof, magic. I'm
okay.